Hello, this is Dead Hamster. Today we're going to be doing a new series. This is going to be called Making a Mod. It's going to be showcasing all the work and some of the more technical details that go into actually making and producing a mod. In this case, it'll be the Tarmac64 Editing Kit and OverKart 64 project, both for Mario Kart 64, both of which I'm the lead developer of. I think it'll be interesting to be able to give some insight into how this process works and how the actual modification is done as far as how the changes are implemented into the game code. I think that there may be some people who have some interest in this topic but aren't technically inclined enough to actually approach it and do it themselves. To properly do this topic justice, I really feel I would have to give a brief history into the Mario Kart 64 modding history. That would start, as far as I know, with custom kart textures with Pit Stop, which was made by MIB. This predates the arrival of custom levels, but it's not really relevant to what we'll be discussing. So the first instance of custom levels would be from Rena, and that's in 2009. Was their Starlight course, which was a custom set of rectangles floating in space. Not very professionally done, made in a hex editor, but it is the first instance of custom levels in Mario Kart 64, and again, this goes back to 2009. I want to say it was sometime around 2015 to 2018, don't know the exact year, where Micro 500 made the first really well-made, well-designed custom level in Micro Mountain. He had made this through Blender, the modeling program, and exported it with a Python script. It was specifically tailored to that model, but it was the first legitimately made custom level, and it's very exciting to see something like that. Shortly after that, year or two, is when I first stumbled upon the scene interested in custom levels for Mario Kart 64. I found that none had really been made outside of those two, and there really was no toolkit or editing program for making these. Thankfully, Micro had taken detailed notes, as had Rena, as to how all of the structures and where all the geometry was supposed to be, and so we were able, or I was able rather, to write my own script in 3ds Max for exporting geometry and program to process that and then put it in. To really showcase what needs to be done with that, you need to look, and I'm going to now bounce over. Looking at a level here, we have the whole course geometry. For Mario Kart 64, it's not just rendering the course. The game was a 4-player split screen game, and that has a lot of difficulties with accurately culling geometry so that you don't overtax your video processor. So most games will just have a single camera view, and they cannot draw anything behind the camera and just remove that from the display. When you have 4 players, though, you're going to be pushing the hardware so much already that you really need to be as strict as possible with the geometry that you're drawing. The solution that the lead developers for the game came up with was to separate the level. This is the surface geometry here. You can see, let me see how it matches up with the actual course geometry pretty well. So you'll notice also that it's color coded. Each one of these represents a different section of the level. Now the game will determine what section you're driving on, and then if you're facing north, east, south, or west, there's a tailored list that was manually curated by a developer that shows exactly what objects should be drawn from that area. Again, this is a developer going in the game, looking at the objects, saying this one let's get rid of, this one let's get rid of, testing, to find the perfect list that would draw the least amount of geometry. Imagine this must have taken a huge amount of time, and it must have been a nightmare to do. All the much more to them. Thankfully, our system is much better. We have a much better toolkit for that, but it is still a very, very tedious process. There's also lists of path markers for the AI, which have to navigate the course. There will be objects such as trees and item boxes and all sorts of other things that are in there as well. All of this has to be processed and stored, and that is where the Tarmac program comes in. So this is the Peach's Castle level that I've made based on, of course, that outside area from Mario. So you can see the set of path markers here. This second set was from a debugging course. Don't pay attention to those. There's also all sorts of trees that you could see that these little green boxes represent, as well as the item boxes. All of this can be placed and manipulated in the editor. We also have our list of section views that we can do. I've gone into detail with a tutorial on how this program works, so I don't want to showcase all of that again. What I do want to stress though is that all the things that you see here, all the custom objects, the trees and where they're located, the path markers, the geometry, the textures, all the texture settings that are available, the scrolls, the amount of pixels that it'll scroll each frame, the surface geometry, the type, all the different settings of echoes, color, camera paths, the sky colors, where the mini-map is, all of these things have to be saved and stored, and then we have to load it back out and process it later. There's going to be a whole set of code detailed to loading out all these structures and figuring, again, we have to determine what's the best way to store these values, what values do we need to store in order to process this properly. Then we have to be able to fit all that, tell the game where it's going to be so that we could load it out later. So it's not just about how many echo paths do you have, but where are all those paths in this huge chunk of data, level data that we're going to be loading out. Again, that's quite a process in ordering and listing out the positions of all this stuff, and all that ends up getting loaded by the next step, and that's going to be our main program here. So most of the code that we write is going to be written in C, the programming language C. We do, however, have a small amount that's written directly in assembly. Most of our assembly code is written for hooking, is what we call it, into the original game functions. So what that means is that we have the original function, let's say, for displaying the screen. We might let that entire function play out, and then the last couple lines of code, we insert our own code that jumps to a new function, and then we display whatever we want to draw on the screen, and then go back to where the original function ended and just return and let it go and continue as though nothing happened. So we might hook into things like the game code that's running every frame, getting hit by a shell. Perhaps we want to have a reaction to getting hit by a green shell. The main menu so that we can display our own title menu. There's all sorts of hooks that we have. Some of them are very specific, some of them are broad that we use for a wide range of topics. But for the most part, we rely on 4 hooks and then a few a large number of specialty hooks for specific instances and specific pieces of code. This will do things like we co-op the collision for all the items so that we could track when we hit another item and respond to that. We change how we display items so that we can draw new ones. All this stuff has to be jumped into the original code so that we can process our own. The main relevant thing for us is going to be loading out and processing all that level data. So again, we have the tempos, we have the path markers, we have all the trees, all the custom objects. We have to go through after we load that chunk of data. So as we process the menu, we're on the level select and we hover over our custom level. It's going to say, okay, well, let's get all this stuff into place, load this here and this chunk of custom object data and this chunk of path data. The level's ready to play, so when you hit A, then it can start setting all those settings up. That's what all this background code does. Again, I'm not going to go into detail on specific functions. This is meant to be a broad overview, but the general gist is that we have assembly going into the original game functions so that we can run our C code, which is much easier to process and read and write higher level. And that's where we run all of our processes to load that custom data that our editing kit put in earlier. So that is the gist of how the whole process works and how we go from raw data in a 3D modeling program to processing that into game ready data, putting that into the ROM, actually loading it out and putting it where it needs to be in memory when the game is running, and then letting the game run and having our custom levels play out. We now have all sorts of exciting things. We have, custom objects, we have red coins, gold coins, as new game modes, custom levels with scrolling textures and translucent textures, and all sorts of exciting things that we're still working on as well. There will be new exciting things to come, and that's what this series is going to be about going forward. I'm going to be making regular updates showcasing what we're working on, what type of new processes we're putting in place, what type of new features, and just kind of showcasing again some more of the background work that goes into to making a mod. So I hope that you guys enjoy this. I hope that you do have some interest in this type of this type of project, and if so, please do let me know. I appreciate all the support as always. The community has been wonderful, and it's so great knowing that there are people out there that just enjoy the work that you're doing, and I want to thank all of you so much for all your support and kindness. It really has been wonderful being able to work on these things, and so I'm really excited for what's to come, and look forward to it. Until next time, as always, you guys take care.